Hey guys, welcome to our proof unit day 2. Recap from yesterday, we were able to explain how after a reflection, which this could also be done after our translation or after our rotation, after our reflection that we had in our example from yesterday, if we were to reflect one triangle onto the other triangle next to it, we could map or match up a bunch of the corresponding sides and angles. So if this triangle was reflected, then we talked about how side AC would map or fall onto side JL. So those would be equal corresponding sides. BC at the bottom would map onto LK at the bottom. So those are equal congruent corresponding sides. And then AB would correspond to JK, and those are also congruent corresponding sides. We could do the same thing with the angles. So with all the transformations that we did last unit, with the rotations, translations, and the reflections, we moved our shape to a different location, but kept it the same size. What we're going to do this unit, and the focus of our proofs, is to show that two shapes are congruent without having to do the constructions to show that one shape could be put on top of the other. That's the idea with our proofs, is to do the same thing, show that the two shapes are the same size, only without the constructions. We talked about different rules and reasons that we would use in our notes yesterday, and then did some practice with those rules and reasons. And now we're going to put these into a real life situation and do some actual proofs. So let's do a first quick homework check. So these are the answers to last night's homework. So look at your pages and let's see if your results match my results and make any adjustments as necessary. The big one that I need to make sure that you have correct is number 3, because this is one that is quite frequently done incorrectly by students. So if we fix it now at the beginning of the unit, you can do it correctly for the next 3 weeks and the rest of the year as they pop up on your weeklies as a review. So the symbol that was given in question 3, it was a symbol for perpendicular. Perpendicular means lines that intersect to form right angles. That's all perpendicular means, is we get right angles. As a result of having those right angles, then we could do a separate step that must come afterwards. We could do a separate step that says all right angles are congruent. But you need to explain that you have right angles first. When I asked in class, what's the definition of perpendicular, and what you're going to write on your weekly when I ask what's the definition of perpendicular, lines that intersect to form right angles. That's it. Now, separately, all right angles are equal, but that's an afterthought. Okay, so what are we doing today? Today, we're going to talk about triangle congruence. Now, if two triangles are congruent, that means all of their corresponding sides are equal in length, and all of their corresponding angle measures are also equal in size. In many cases, we don't have to show all 6 parts of information to be true to say that triangles are congruent. There's 5 shortcuts to this. So every triangle has 3 sides and 3 angles. That's 3 or 6 pieces of information. 3 pairs of angles, 3 pairs of sides. That's a total of 6 pairs of information. We don't need to show all 6 pairs of information are congruent between the 2 triangles. There are some shortcuts. So our first shortcut is called side angle side. Side angle side congruence. Side angle side means if you have one side of one triangle congruent to its corresponding side, the angle in between and a second side congruent to the other triangle, that is enough information to say that all the rest of the pieces of information are also congruent, so the triangles are congruent themselves. So if you have side angle side, those 3 pieces in that order, congruent between 2 different triangles, all the other pieces fall into shape. So going back to thinking about or imagining what we talked about yesterday, we lined up all 3 pairs of sides and we lined up all 3 pairs of angles. What I'm saying now is when 2 triangles are congruent, you will get those 6 pieces of congruent information, but you don't need to explain why all 6 are congruent. the first shortcut that we're going to deal with or work with is the side angle side. So you only need 3 out of the 6 pieces of information as long as they're in the right place. So the piece that's important here is that the angle must be included between the congruent sides. It's called side angle side for a reason. It's those 3 pieces in that order. A side, in order to turn to the next side, that's the angle that needs to be congruent. It's the angle that's in between the 2 sides. It's the included angle. Side, angle, side. If you can prove those 3 pieces in that order are congruent between your 2 triangles, then that's enough to say the triangles are congruent. So let's make sure we can identify side, angle, side. Side, side, where's the included angle? Well, the included angle would be the one that connects those 2 sides. So that's the angle that you would need to prove side, angle, side. The angle in between the 2 congruent sides. If it's side, angle, side, then that's our second side that we would need. Side, angle, side. That's the other side that we would need to prove our 2 triangles are congruent. So hopefully you did okay with the homework yesterday. And hopefully you remember that every first step always starts with the givens. Now, yesterday you were able to practice just filling in the blanks based on either the given information or fill in the blanks because you were told what one of the reasons for the statement was. You had to fill in the other thing. That's not how most proof works. Most proofs work by you given a little bit of information at the start and you have to figure everything else out on your own. What you're supposed to do with the given information is mark it on your diagram before you do anything else. So we are told that the measure of angle CBA is equal to the measure of DBA. So from C to B to A, that's this corner right here, is congruent to angle DBA, D to B to A, that's this corner right here. Those 2 angles are congruent because that was given to us. We were also told that CB is equal to DB. So CB is here, DB is there. We are asked to prove that the 2 triangles are congruent. Now this is easy to see which 2 triangles we're talking about. It's triangle CBA and triangle DBA. We're trying to get those 2 triangles congruent. At this point in your life, the only way you know to get those 2 triangles congruent is using side, angle, side. We are already given one side and the included angle. That means we need the other side. Where is that other side? In order to go in the correct side, angle, side order, what would be the next side in our picture? Side, angle, side. So it would have to be side AB from triangle CBA and triangle AB from triangle DBA. What was the rule or the reason that said side AB is congruent to itself? Because that same side is used for 2 different triangles. Reflexive property. Reflexive property is congruent to itself. Now that we have a reason why side AB to the triangle on the left is congruent to side AB to the triangle on the right, now we have fulfilled our side, angle, side obligation, and we can say that triangle CBA is congruent to triangle DBA. And the reason I know that those 2 triangles are congruent is because we have just proven side, angle, side congruency. Congratulations! You just finished your first official triangle congruence proof. Yay! Some of you asked yesterday, why are we using congruence? Why not equal sign? You can see right here in this example that there are equal signs and congruent symbols mixed. So how do you know when to use which one? I just noticed I got to answer this question before we move on. What single transformation will map CBA onto DBA? That would be a reflection over side AB. So if we just folded our paper in half on AB, then the two triangles would end up on top of each other. Okay, so back to equal versus congruence. Equal sign implies the use of numbers, and congruence does not. So if you wanted to use an equal sign, you can, but you need to make sure you use it accurately. So if you're using an equality notation, an equal sign, you do not put the bar over the symbols or over the letters that represent the segments, because two letters without the bar over it means the length of that segment or the distance from one point to the next point. All right, so two letters without the bar over it means the distance of that segment or the length from one point to the other. If it does have the bar over it, it's talking about the physical shape that is that segment. So without the congruence sign is without the bars. For angle measures, you can say that the angle A is congruent to angle B. The congruent symbol means they are the same size and the same shape. If you want to use an equal sign, which implies the use of numbers and they are the same angle measure, then you would say the measure of angle A equals the measure of angle B. So without the squiggly part over the equal sign, you have to then include the M for the measure of angle. That implies the use of numbers to say the two angles are the same size. All right, now that that's taken care of, let's do another proof. We are given that Km bisects Jn and L is the midpoint of Km. That is given information. But as given information, it doesn't actually give me any congruent parts that I can mark in my diagram. Yes, I know what bisect means. Yes, I know what midpoint means. I know where that's going to lead us, but we don't have individual parts written down yet. So there's nothing to mark. That's the point of having the proof. You have to interpret the given information and figure out how does that get you equal pieces? What equal parts can we say is true from that given information? So I guess we'll start with what they gave us first, bisect. I asked you a bunch of times yesterday, what does bisect mean? Bisect means cut in half. So if Km bisects Jn, Km cuts in half Jn, that means JL is congruent to NL. JL is congruent to NL because, as we wrote down yesterday, bisectors create two congruent parts. Since those parts are congruent, we mark them with a single dash on each one to show that they are the same. Next piece of given information is the word midpoint. Midpoint is called a midpoint because it is the point in the middle. So if L is the point in the middle of Km, what pieces are equal? If it's in the middle, that means it's the same distance on both sides. So which pieces are the same on both sides? Well, if L is the midpoint, then from K to L is the same as from M to L. Because a midpoint creates two congruent segments. That would put KL the same length as ML. Now, in order to do side angle side, we need another side. Oh, no, we don't. Silly me. We need another angle. So side, angle, side, we need the angle. We need a reason why those two angles that are in between our two sides, we need a reason why those two angles would be equal. What kind of angles are those? If you don't know, I'll give you a hint. It rhymes with vertical. Vertical angles are congruent. Remember that from September. So that means that angle JLK, and the L has to be in the middle. The order of the other two letters doesn't matter, but L must be in the middle because that's where the vertex, the turn is. JLK is congruent to NLM. Because vertical angles are congruent. Now, if for some reason you decided to use an equal sign, you would say vertical angles are equal. I use the congruent symbol, so I said vertical angles are congruent. All that wonderful work is now enough for me to say why my triangles are congruent, because we have satisfied the side angle side criteria. So now I'm going to copy what they asked me to prove down here. Triangle KLJ is congruent to triangle MLN, and our reason is side angle side congruency. Your letters must be in the correct order. So you have to show that angle K is congruent to angle M. So angle K is congruent to angle M. They have to be in the same position. And then angle L would match up with angle L. That's the one on the left would match up with the one on the right. They're vertical angles, so those are equal. And then angle J and angle N, angle J and angle N, those are the corresponding pairs that match up. So your letters have to show which angles are congruent. So the order does make a significant difference. You have to make sure that it's correct. What you should do when you get to that point is you can just copy what they asked you to prove down on your proofs line, because they'll give it to you in the correct order. Just copy it in the correct order. All right, let's do one more and then I'll let you go practice. Always start with the same thing, and that is our givens. So we are given that BD is perpendicular to AC and D is the midpoint of AC. It doesn't matter if we do the midpoint first or if we do the perpendicular first. So if you want to go ahead and try this on your own, go right ahead. You can either do the midpoint first or you can do the perpendicular first. If you want to just wait for me, take a deep breath, hold on a second, and we'll get started. I'm just giving the people who wanted to go ahead a little bit of time buffer so they can get ahead, which is why I'm kind of just rambling and talking here, buying a couple more seconds of time while the people who went ahead get a little ahead. And those of you that want to do it right with me, just take another deep breath. Okay, here we go. So I guess I'm going to do the perpendicular first only because it was listed first. It wouldn't really matter. Perpendicular, definition of perpendicular, two lines that intersect to form a right angle. So my right angle would be BDA and BDC. Angle BDA and angle BDC are right angles. And I know that because I'm smart and I know that perpendicular lines form right angles. This is just like what we did yesterday. We did this in the notes, and then you had to do another one on the homework. And I even was talking about how this is one of the important things that you have to be careful of. Perpendicular means lines that intersect to form right angles. That's it. We're done with our perpendicular. But yesterday we did something else with this. As a result of them being right angles, and all right angles being 90 degrees, that means that angle BDA is the same size and same shape as angle BDC. So they are congruent. And the reason why they are congruent is because all right angles are congruent. So that gives me a pair of equal angles in order to try to satisfy my side angle side criteria. So I have the angle part taken care of. Now I need a pair of congruent sides. Well, we were given a midpoint, so I guess I'll use that next. If D is the midpoint of AC, that means that it is the point in the middle, creating equal parts on both sides. So AD is congruent to CD. Because a midpoint creates two congruent segments. Midpoint creates two congruent segments. So I want to mark that, and that gives me another pair of sides. At this point, I have exhausted all of my givens, and I have no more givens left to deal with. So that means in order to get the third side, or the next side for my side angle side criteria, I got to figure out something on my own. So if I look at the two triangles we were trying to prove congruent, I got this one over here, trying to get that congruent to this one over here. So those are the two triangles we're trying to prove congruent. The issue is, how do I get another side in order to make that reality? And that's going to come from BD as the side that is used with both triangles. Do you remember the property? Uh-huh. So that's our reflexive property. So we did it. We have done side angle side. So now I'm going to copy down what I was asked to prove. A, B, D congruent to triangle C, B, D. And the reason why I know that's true is because through my proof and the reasonings that I used, I proved that side angle side criteria works. Okay, so you still got around little less than half the class left. So work on the homework and practice. And then if you get that done, you can also work on the weekly. Please be nice to the sub. Keep your phones in your bags and just do what you need to do. I will be back next class and we'll keep going. All right. So you take care, be well, be safe, all those good things, and goodbye.